Presenter for tonight. Hold on one moment. Our first presenter, hold on one moment, let's make sure you have. Let's try this again, much better. Our first presenter for the night will be Brian Cunningham.
Hey babe, what's up? Me? Yeah. Oh, what's up?
Thank you. All right. Hello, everyone. Thank you for being here today. My name is Brian Cunningham,
cool. Well,
and I'll be presenting my
right now,
GIS-C final project titled Deploying an Open Source GIS Application to Identify and Rank Undeveloped Parcels in Pima County, Arizona.
This is nice.
The agenda for this talk, first we'll start off with the study area, then the project purpose, then the objective of the project, the methods used to build the model, then the results of the model, then we'll finish with the conclusions. The study area for this project was Pima County, Arizona, which is a region in southern Arizona with over 900,000 residents, over, a land mass of over 9,000 square miles, and multiple jurisdictions, and over 420,000 distinct parcels. The purpose of this project, the primary purpose, was to develop an application with an intended audience of real estate professionals and market researchers, where they would have a web map platform to give information for parcels, such as the owner of a parcel, its development potential, and any constraining areas within the parcel. There's also a secondary purpose, and that was to utilize open source GIS. And I'll talk about more of that in the presentation. Similar studies have been done, primarily with commercial software. For instance, in China, Sun and Zhu in 2009 developed a spatial decision support system for real estate appraising. Also in China in 2015, Su used SuperGeo and inverse distance weighting methods to analyze the market trends in China real estate. In 1997, in England, Wyatt developed a spatial decision support system for land appraisal. In 2010, the city of Portland, Oregon developed a comprehensive land use model using GIS to identify underdeveloped and underutilized parcels. Why did I choose open source for this project? The first reason was we wanted to save money. Organizations can save money using open source GIS. It's estimated that most commercial software is going to cost between $7,000 and $10,000 a year just for a license, not counting yearly maintenance fees or any annual licensing fees. Second reason why I chose open source is the freedom. As my friend William Wallace represents in the picture, this sense of freedom that open source allows you to see the source code, know what's going on behind the scenes, and a programmer can build off of that and add to it. It allows for more sense of control for this project. The first objective of this project was to design the open source architecture. This required identifying the proper open source technology to use for this project. And 8 different open source softwares were used: WinSCP, 7-Zip, PostGIS, PostgreSQL, QGIS, also known as Quantum GIS, GeoServer, curl, and OpenLayers. The next objective was to gather the data. And this consisted of 2 main sources for the data. First being the Pima County GIS FTP source, File Transfer Protocol. This is a source of approximately 65 GIS layers that are updated nightly by the Pima County GIS office. The second source of data was the 2015 Pima County Tax Assessor data, which was a yearly record of values and properties for each parcel within Pima County. This image displays the work processing for bringing in the data, extracting it, transforming it, and loading it from the centralized database into the web map. You can see WinSCP is first used to automatically connect to the file transfer protocol for Pima County. The data comes in as zip files, and 7-Zip was used to extract the data within a batch command. The next step was using PostGIS and a batch script to load the data to the centralized PostgreSQL database. The model also ran within the PostgreSQL database. After the model was run, the results were implemented to QGIS and analyzed, and the initial styling and the initial publishing was done from QGIS. The data was published to GeoServer, and Crow was used to build the automatic updates for the data on a weekly basis, then the web map created with open layers. Next objective was to construct the model. This consisted of two main formats. The model depended on two main properties: the data going into the model and the methods being used within the model. The first set of data, called the base data, this consisted of the parcels for Pima County, the 2015 tax assessor data, and the land use codes, such as whether it's residential, commercial, or vacant. There's another group of data called the constraints. This consisted of areas where parcel development is off limits and not available. For instance, wildlife habitats for endangered species, such as the pygmy owl, state-owned lands, which are lands that are within the state trust, federally owned lands, such as lands for the BLM, and designated airport zones. These are zones that are designated for future airport growth and also for noise regulation for the airports. Next, an improvement to land value ratio was implemented, and this was borrowed from the City of Portland's 2010 study. This, this ratio is calculated by taking the improvement full cash value, also known as the IFCV, and divided by the land full cash value, also known as the LFCV. The results are multiplied by 100 to receive a percent, and this equals the improvement to land value ratio, also known as the ILVR. The lower the score, the better, the more higher potential for development. And the results were categorized into three groups: low potential for development, medium potential for development, and high potential for development. The methods used for the model consisted of SQL queries and geospatial SQL queries. This was interjoin, union, intersect, erase methods, add and calculate fields, dissolve, also known as an aggregate function, and summary statistics. This workflow demonstrates the overall process of the model. See at the top, the three base layers, point here, in this area, are the base layers, which are joined by an inner join off of a relational key for each parcel, and along with the land use codes. Then the improvement to land value ratio is calculated, and in another sub-process, the constraint layers are unioned in order to create the areas off limits for development. Then an intersect function is used to determine which parcels fall within the constrained areas, and these parcels are omitted from a further analysis. Then there's two outputs for the layer. One with the improvement to land value ratio for each parcel, which is stored in the centralized PostSQL database. Then a separate layer for summary statistics for a calculation of how many parcels fell within each development category. This is the model code. Decided to use SQL spatial code for the overall model, and chose this option over Python or any graphical modeling option because I felt this was more flexible and also more dynamic and could be used within other platforms. I built this with PostgreSQL, but a similar code could be used with SQL Spatial or Oracle Spatial, just with a few minor tweaks. It may look intimidating. If you break it down to just 5 groups, the first function is creating the improvement to land value ratio. Second statement is a case statement to identify the development potential for each parcel. The third statement is identifying parcels that are considered vacant land, also known as undeveloped. Then the fourth query is a subquery to create the constrained layers and union all these layers together into one. Then an inverse intersects method was used to create the parcels that are without constraints and meet the potential values code. And next. This map shows the results of the potential for development throughout Pima County. You can see a random distribution throughout Pima County, and over 38,000 showed high potential, basically meaning they didn't already have any improvements on the land. Only 39 showed medium potential and 34 with high potential. This map was created with QGIS, but it's limited in one function. It doesn't allow users to interact with it or be able to get information for a parcel. Therefore, the next objective was to publish the model results to a web map. And using the OpenLayers 2.13 API with some JavaScript and HTML5, was able to build the parcel value land map, web map for it. The user has the ability to turn the vacant layers, undeveloped layers on or off, to zoom in, and to change base maps. And also, for user interaction, the user zooms in, clicks on a parcel, he or she is given the information for that parcel, such as the landowner, the description of the parcel, and the improvement to land value ratio towards the end. As I mentioned, the user can change base maps, such as this base map represents the Bing satellite imagery, which is useful because depending on how often this image is updated, a user can zoom in and see, is that land actually undeveloped? This is the web map URL, the location for the web map. Feel free to check it out, interact with it, and see what you think. Future plans for this project. First, we'd like to incorporate more tools within the web map, such as I'd like to incorporate a query function to where a user can type in parcel index numbers and either zoom into that parcel or receive a report off of that parcel. Would also like to include a distance distance function so that a user can measure and see what may be in the surrounding areas. Second, I'd like to adjust the model for surrounding features to incorporate any proximity to roads, proximity to floodplains, or if it's in within floodplains, and also to see if the proximity to hospitals or any other factors, and adjust the model off of these factors. And third, I'd like to look at the water requirements for development. Pima County, being a water-stricken area, may not be feasible to build a residential property, then not be able to provide the water for it. In conclusions, the GIS application was complete. A web map and one platform was built to where users can interact and receive information for a parcel and know if it can be developed or not. The development potential in Pima County was realized. There's a high factor for development in Pima County. The model was successful in identifying and ranking the parcels for development potential, and open source platforms are a valid option to use as opposed to commercial software. This concludes the presentation, and I welcome any questions or comments. Thank you.
Thank you, Brian. Let's give Brian a round of applause. So are there any questions?
None at all?
Okay, Brian, I have a question
Sure.
to start off. I was wondering if you could explain why you chose to use vector analysis instead of raster analysis for this project.
Vector? Yeah. Well, sorry, some feedback there. Okay. I chose vectors because that's actually how the Pima County FTP data was set up. And developing the scale for rasters would have been more difficult, and it was just easier to work with the vectors in this situation. Also, with the SQL commands, working with rasters is very difficult because of the scale, and also there's higher error seen with raster and spatial queries.
Would you consider using raster analysis if you were to expand on this project?
Because of the old cliche, raster is faster, but vector is corrector. In that, because of it, raster would have been, I just don't see it would have been as proper for this type of analysis, maybe for some suitability models, but not this one.
Okay, thanks. Any other questions from online? So if you're online, you can just ask a question directly. Or if you're in person, you could ask a question.
Hey, well, thank you.
Great, well, thank you.
Let's Okay, thanks again, Brian. Okay, so our next presentation is going to be actually at Julie's presentation at 6:05. So the way that it works with these presentations, because some people will be tuning in right at the time, on the schedule for the presentation, we're actually just going to take a break. So I will see everyone back here at 6:05. Actually, before that, Iris has a quick announcement about the Esri conference. So go ahead, Iris.
So the announcement about the Esri conference is on Monday, the presentations occurring in San Diego at the Convention Center. We won't have confirmation of the room number until Sunday. And so check your emails on Sunday to know where the location for the presentations will be on Monday. All right, and that's it for me.
Okay, thanks. So we'll see everyone back here at 6:05, or 6, so a little bit before that, 6 o'clock.